Okay, guys, in this video, let's take a look at how to find the magnitude or length of a vector. Okay, so here we're going to have magnitude of vector A. Okay, and how do we find it when we have components? So we know that has components 3, 7. So what would that gonna look like? Well, let's just start at the origin. So if we start at the origin, we're gonna go 3 to the right, and we're gonna go 7 up, right? So 1, 2, 3, 4, 5, 6, 7. That's gonna be my vector, right? And so what you can tell here is that when you look at the vector, right, you can tell that the height over here, the height is going to be your 7, right? And the length is 3. And so by Pythagorean theorem, this third side, which is the length or magnitude, is going to be square root of the first side squared, short side, plus the second side squared. Okay, so general formula for magnitude of a vector. Now, this is for 2 dimensions, but it's also going to extend to 3 dimensions, the same thing. So if you have the components, you're just going to take, let's say, the x component ax, square that, and then plus the y component, square that, and then take the square root. So for me, it's going to be 3 squared plus 7 squared. Now, you are not supposed to convert to a decimal. Most of the time, what they want to do is just leave it as a square root. So if you want to compute it on a calculator here under resources, you're just gonna only compute what's under the root. And then once you get that, then you're just gonna put the square root after that. So just don't forget that. Also, if any of the components have a negative, or like for example, -3 or -7, something like that, that is not going to affect the magnitude, because when you square, the negative will go away. So my strong suggestion is to never write a negative. So for example, if this was like -3, 7, some people do that. And that is wrong, because this negative is outside. So if you really wanted to be like a stickler for it, then you would have to do this. But why? I don't see a point just to get yourself confused. So whether it's positive, negative, doesn't matter. Do not put the negatives in there, because they're going to go away anyway. Okay, in terms of magnitude of B, we already know how to do that, right? So we have the initial point right here, and then we have a terminal point. So when we want to compute the magnitude, when we want to compute the vector B in component form, we're going to subtract, right? We're going to start with the terminal point, x coordinate, subtract the x coordinate of the initial. And then again, y coordinate or terminal, subtract the initial. So terminal minus initial. So this is going to be -5, -3, right? Okay, so let's go ahead and put that in here. Finally, let's perform the operations on vectors. So when we perform the operations on vectors, we're really just going to do the operations on their components. So first, we're going to take 2a. So I'll just write over here, and Desmos is going to complain, but it'll get over it. Okay, so 2 times a, what is that? So that's going to be you taking a and multiplying it by 2, which means each component gets multiplied by 2. Okay, and then you want to subtract 5 times b. Well, we just found b, so that's -5, -3. So let's multiply that by 5. So we're going to get -25. And then 5 times -3, -15. And now we just perform the operations by like the x minus x, y minus y. So 6 minus 25. What is that? Well, that's 6 plus 25. So that's 31. And then the other one is going to be 14 minus 15. So that would be plus 15. So that would be 29. So hopefully that's right.